Greetings and good evening to one and all. On behalf of IEEE Computer Society Madras, ACM Chennai, and CSI Chennai, I extend a warm welcome to our today's distinguished speaker, Dr. Shajulin Benedict, participants who have joined the Google Meet and watching the YouTube streaming of today's webinar, and my colleagues from all the OUs. After the mass adoption of cloud and fog computing for various applications related to digital transformation across the globe, the edge computing has become a major development with the increase in IoT devices connected across the net in billions in number. In the recent years, IoT applications have marked an increase in dimensions across domains such as industries, agriculture, financial, transportation, healthcare, and so forth. With a large number of geographically widespread connected devices, transporting sensor data across networks to clouds has become a challenge for an effective implementation of associated IoT analytics with generic IoT cloud architecture to meet the critical needs of applications. In addition, handling privacy of sensor data such as images, videos, has raised concerns for fruitfully implementing the analytics in such architectures. The inclusion of edge nodes eases the learning process for IoT-enabled applications. This talk will emphasize on the importance of edge nodes and associated architectures for performing learning interfaces. Now it is my pleasure to formally introduce our speaker, Dr. Shajulin Benedict. After his engineering from NEC MS University in India with distinction in 2001, Dr. Shajulin completed his ME degree in digital communication and computer networking from Arulmigu Kalasalingam College of Engineering, Anna University in the year 2004. He was the university's second rank holder in his master's degree. He did his PhD in the area of grid scheduling at Anna University, Chennai, under the supervision of Dr. V. Vasudevan, Director, Software Technologies Group, TIFAC Core in Network Engineering. I suppose Dr. Vasudevan seems to be participating in the meeting. I just noted one name, V. Vasudevan. I suppose he is your guide. After his PhD, Dr. Shajulin joined a research team in Germany to pursue postdoctorate under the guidance of Professor Gerent. He had served as professor at St. Xavier's Catholic College Engineering Research Center of Anna University, Chennai, for a brief period. Later, Dr. Shajulin visited Technical University Munich, TUM, it's called TUM, Germany, for teaching cloud computing as guest professor. Then he joined the Indian Institute of Information Technology, Kottayam, Kerala, an institute of national importance of India, to teach the subject Internet of Things to the international students of TUM Germany as guest professor. She also serves as director as well as principal investigator and representative officer of IEEE-CSI-ACM Kottayam, a Section 8 company, an incubation center under Adult Innovation Mission of Government of India for nurturing young entrepreneurs in India. His research interests include edge and cloud analytics, performance analysis of IoT applications, IIoT, that is Industrial Internet of Things, blockchain, and so forth. Currently, he is a guest professor for a semester at TUM Germany. Right now, he is going to deliver his webinar from Germany. With this brief welcome note and introduction, may I request Dr. Shajulin to enlighten us on edge intelligence in IoT applications. Over to Mr. Dr. Shajulin.
Thank you so much, sir, for your introduction. Also to CSI Chennai. Let me share the screen. I hope it's visible to you.
Yes, visible.
Okay, so welcome one and all who are present here for listening to this talk on Edge Intelligence for IoT applications. Yes, a few projects I have done in the past. Also, currently, I am looking into this IEEE-CSI-ACM Kottayam for incubation process. So let me quickly jump into the topic, Edge Intelligence. So today's talk basically will be in this flow. Like first, I will briefly talk about what is IoT, then some applications that are subdivided in IoT. And then I will focus on edge intelligence, what are the different learning techniques that are followed, how we could improve this edge intelligence, right? And with little case study, and I will also showcase some research directions that may be here in this domain. I could not see the chat box, so if something is there, we will look into the questions at the end of the session. So, what's IoT? Actually, Internet of Things is very, very commonly used in the past, right? It is about providing internet, right? It has a long history. Initially, it was given for the term RFID, but it was, even though the term Internet of Things was coined in 1999, the real existence of Internet of Things flew in the later stages. What is Internet of Things? Basically, it's extension of Internet, right? So providing Internet to any small device or anything in the world, that is Internet of Things. It's a kind of future Internet. So this means your table, fridge, washing machine, whatever will get connected, and they all will get internet. They will be notified of what we want, right? So millions of computing devices, or billions of personal devices like your laptop, mobile, and smartwatch, glasses, and so on will get connected. They will get internet. And trillions of sensors like pressure sensor or flow sensor or whatever, all these sensors will get connected to this ecosystem. So Internet of Things is typically a future internet where lot of possibilities are there. Like recently, people were talking about the metaverse, right? To keep the society smarter, to keep you more productive. It was, in fact, in the earlier stages, it was talked like in 2050s, robots will be there throughout, right? But nowadays, if you look into the technologies, like people were discussing about the metaverse and so on, where you create avatars, and these avatars are going to talk to you, communicate with you, be friendly with you, and so on. So these are some kind of objects that are going to get some sort of connections, and they bring a kind of lively atmosphere for you to keep you more productive. Also, recently Apple also was trying to put forward the idea of this glasses, right, with virtual reality and so on. So these are all wearable devices which will have internet and some sort of computation, some sort of intelligence will be there to assist you, right, to provide some support to you during your lifelong journey, right? So obviously the society becomes knowledge driven, right? Everyone gets knowledge from all these small tiny devices that are around you. If you want to write a textbook, you get information, you get more productivity just through the devices that are around you. Like nowadays, people try to use Siri or no Alexa, right? In older, at least most of the time people use Google to search what is the content. Nowadays, this trend is changing a little bit, right? They started to use these devices, and they talk to the device, and the device is communicating to them, right? Say, what is the meaning of this? What happens to this, right? Can you translate this? Can you play music to me, right? All these things are directly given to the devices, and the devices are communicating to us. So devices are little bit more intelligent, right? We provide intelligence to them. So this is something that is near to the end system, as like a human being having a lot of sensors to process the information. Likewise, in sensor world, you have so many sensors that are sensing the information, and that is trying to fill the application that is, or the objectives that has to be fulfilled. Right, so you can expect some sort of cognition-enabled machines that are talking each other, and most of the devices that will be around you will be in airport, gyms, and so on. All will get connected, and they will try to keep you more productive. So, Internet of Things, simply just like a feature internet, is having a lot of potential, right? If you see the trend here, you can easily observe that the trend keeps increasing continually, right? It can be observed from the patent. You can see the companies that were involved. You see this particular chart, which was taken in 2018, is showing how the number of patents were filed by some of the companies. Let us take the example of this Samsung, right? And see the graph, which was, or the patents that were filed in 2022, right? Or the number of patents filed till 2022. You can see a tremendous growth in the patenting. This shows that the innovations are improving, right? Entrepreneurs are finding a lot of opportunities in this IoT field. And just with the keyword of IoT, I am just showing you the number of patents that are there. And it is not just with the entrepreneurs as well as the companies or industries. It is also with the researchers. The researchers are also showing a very steep growth in the number of publications that show with the Internet of Things world. This shows that there are so many potential growth in IoT. And without money, there is no real growth. So I have just shown here the investors of IoT, which clearly highlights, like 2030s, you can expect around $1.5 trillion investments, which will go towards this IoT field. It's not just I am putting some statistics, it's coming from different sectors where people highlighted that this IoT is definitely growing. And it is not just for computer science discipline, right? It is to several sectors like agriculture, retail, healthcare, automotive, logistics, manufacturing, and so on, so on. Right, so a large number of developments are happening in this IoT field, and typically, if someone wants to start their research or they want to develop some products, it is worth investigating on this particular field, because you can connect with many different topics like smart cities, connected industries, connected building, connected car, and so on, so on. And the statistics which you can see are typically valid ones, which shows that IoT is definitely a growing sector. Of course, IoT is having some grassroots, or it has some roots to cloud. Right? If you see the existing platforms which can develop IoT applications, right, which offer the people to develop IoT applications are coming from cloud background. Like if you talk clouds, right? Cloud computing, which is resource sharing in a virtual manner as a pay-as-you-go model, and so on. These cloud systems who offer this infrastructure as a service or some stuffs like that, right? The top cloud infrastructure providers like Microsoft, Amazon, Google, Cisco, and so on, they have provided the infrastructure for IoT. If you see Microsoft, right, you can see typically for cloud it is Azure, right? With IoT you have Azure IoT. With cloud, Google Cloud, you have Google Cloud IoT. With Amazon, you have Amazon AWS IoT. Cisco, you have Cisco IoT, right? So Internet of Things support is already there as a platform for someone who wants to develop IoT solution, someone who wants to develop an IoT application. Now, I would like to highlight that there are also solutions which provides edge, right? Some edge support. I will be talking about edge very shortly, but for the moment, we want to see the trend that is upcoming in this field, right? So, cloud platforms have the support for IoT, and the IoT is also having support to the edge systems. And this is where you can see Azure has support in the term of the product called Azure IoT Edge. Google Cloud, they has the support of Edge TPU. Amazon, they have the support of IoT Greengrass. Cisco has the Cisco IoT Edge, and so on. Right? So the platforms are already there for you. So fundamentally, what is this IoT node doing? Right? We told that it is a future internet where all devices will have different IP addresses and so on, and they communicate each other, they could talk each other and so on. So some sort of intelligence is required for those devices. If you take, glasses and so on, so they have some support for such provisions. Let us see very briefly what this IoT ecosystem will look like. So in very, very fundamental principle, if you see an IoT application will have sensors, will have actuators, and will have the network devices. The sensors are just collecting the sensed information, as like our human body, which has so many sensory organs, right? Like eyes, ears, nose, and so on. For an IoT application, sensors become like something which is going to collect the properties, right? Like temperature property, light property, flow property, humidity property, and so on. And once after collecting the information, you need to do some intelligence, or you need to perform some objectives or some intelligence, basically, right, based on the input what is given to the application. So this is done with the networked devices. The network devices, when I say, it could be some servers hosted on cloud. It could be the servers that are just below the cloud, like a fog node or fog clusters. Or it could be some devices that are very near to the sensors, very near to the sensor objects like edge. Right? So the network devices are typically the hierarchical computational nodes, which stays very near to the sensors as edge or fog or cloud. So cloud typically will have higher scalability and higher computational power. Fog will have less capability, computational capability. It could stay very typically near to the sensors, but not very near to the sensor. Edge will be typically like a computing machine, which is very near to the the sensors, very, very near to the sensors typically. And these are typically like microprocessors with microprocessors or even microcontrollers, which can have little computational power, and it will typically have some support to different communication protocols like LoRaWAN or Wi-Fi, Bluetooth, and so on, Zigbee, and so on. So this kind of communication support it should provide, and it should have some computational intelligence. So in a human body, normally when you get into fire, right, immediately your sub part of your body will act immediately, right? It will not send the signals to the brain, and then the brain will not make the processing, right? As like that, your sensors from the IoT application, it should collect the information, and it should not send the data to the cloud for making the intelligence. Rather, it should do some sort of decisions at the edge itself, right? So instead of sending the signal directly to the brain, to the cloud, you should make the decisions at the intermediate levels. So edge intelligence is typically falling under this part, right? You provide intelligence basically in any IoT application. You will have sensors, you will have actuator, and based on sensory information, you're going to do some action. What kind of action? It could be like moving the motor, or it could be sending notifications, or it may be providing some voice support, and so on. These are some sort of actions. But in between, some intelligence is required. That is where the network devices are looking to. So there are several subdomains in this IoT, industrial IoT. I will quickly go through these subdomains. Basically, you can watch this in one of my previous videos. Of course, industrial IoT is more towards industries, right? Like improving the process that are involved in the industries. Like the machines want to communicate to the next machine, and the machines will talk to each other, and they will send, one machine will send something, and it will do some intelligence, maybe nearer to there itself, like edge device will be nearer to the machine, and it will process that, and it will send the intelligence what it has inferred to the nearest machine, so the next machine could do the next processing without the support of human interference, or without the support of other higher level support, right? So this is a kind of industrial revolution, right? So therefore, they call it as Industry 4.0, and IoT applied for industries. They are termed as industrial IoT, right? There are so many use cases like predictive maintenance, spare part replacement. You can do some replacement of like in car manufacturing sector, you can replace the parts of the car priorly, right? Based on the intelligence that you have inferred, and so on. So that is all about industries. The second part is consumer IoT. The consumer IoT is more related to personal devices. Okay, like as I was talking about, metaverse, creating avatars and talking to those avatars, right? So avatar is like, you create a virtual body, and you leave it around. It will it will just go around, and it will be based on virtual reality and so on. But these objects will also have some internet support to communicate to them, right? So you are talking to those devices basically, and they are communicating to you. Right, in older days, you would have seen people with Bluetooth, earphones, and attached to the mobile, and they keep talking, laughing in the public, and people were confused. What is happening to this guy? Right? Now with this metaverse and so on, in the future internet technology world, it can become even worse. Right, you may not only just talk and laugh in front of others. You are going to even dance. You are going to even live with the with these avatars, which are modeled basically, and typically, it is going to become a havoc if you are if someone is just viewing you. But the person who is experiencing this, he's going to feel something extraordinarily different, right? You may not like some particular character. You might not like a particular society, but still you can live in that society with this system of personal devices connected with you, as like you are enjoying the world. You live to the maximum capacity of the life that you can expect in this world. The systems, the assistants, assisting devices with the sensors and the edge nodes that are there will provide as much intelligence as possible for you to make you more productive, right? So the consumer IoT talks more about the wearable devices, gadgets, fashion items, and so on that will be helpful. And this is more peculiar for healthcare applications, right? Typically for healthcare, for productivity, and so on, you can find a lot of good applications in this sector. It is more to talk about, right? The next subdivision which you can see in IoT is social IoT. This is particularly the IoT system where you collect the social messages from the social media sites and so on, and you try to sense something from the messages, text and so on, which is like big data, right? You have so much of data. As a single person, it is not possible to look into all these social media sites and come to know or get a conclusion that whether a particular friend of you is really becoming a friend of you or not a friend of you, right? As a single person, it becomes difficult for you to assess this. But with IoT systems, right, which comes under this category, social IoT is trying to sense the information from the social media sites and so on to make you update about what is the reality, right? Exactly from likes, dislikes, and so on. So you can understand that you sense something, you make some intelligence, and you perform that based on that intelligence, right? This is this very simple form of IoT application. And there is also a category called Semantic Iot, which talks more about the semantics that are involved in the sensing material that you use. Like you can personalize something. You can personalize such that you get exactly for your purpose. You can tailor the solution for your purpose. Right? It is contextualized, personalized, and tailor-made solution. Typically, it uses OWL-based technologies into it so that you can make more tailored solution there. Productization IoT is another subdomain where you can sense the manufacturing sectors, and you can design based on the machines where the machines will create separate taste and so on, and you can make the productization typically using 3D printers and solutions like that. So these are all some different IoT applications that are very useful, that are mostly available in the market. I hope it's still audible and everything is working fine, because I don't have the... Yes, very good. Thank you. I can hear something.
Yes, sir.
We can hear.
Yeah, very good. Thank you. So the next very core part which we want to cover here is edge intelligence, right? In a broad sense, I already told that as IoT application will have sensors, actuators, and in between you have networked devices. As like a human body, the sensors are sensing, and now instead of making the intelligence after sending the sensory information to the cloud, which is like I'm making an analogous representation here, that you are sending the signal to the brain, and the brain is making the processing. Instead of that, we try to make the decisions right away near to the device, right? So very simple explanation of what now machine learning looks like, because we need to provide intelligence, right? So a lot of data are involved. So a human could not understand, or he could not remember or make sense of from the huge volume of data. So machine is allowed to learn. So therefore machine learning, right? So when machines are allowed to learn something from a lot of data, in fact, it is like, it is modeled such a way that as like human brain is doing, you have neurons, and typically neurons will have some structure which sends something, and based on the sensors, sensory information, some weights will be given, and based on the weights, it make the influence whether to the next neuron, saying whether this is really important or not, right? So as like how the neurons function for making some inferences to make some learning process, here we make the machines to learn like that, right? So we create neurons and create a network of neurons, basically, not just one neuron, network of neurons to create such weights and so on, and try to learn the process based on the sensory informations, right? So if this neurons or the learning is put forward in several layers, right? Several layers, so that you keep the learning more and more accurate, right? Which is very important for large number of applications of sense, like IoT applications. Typically, IoT applications, most of the IoT applications would be based on either image, video, audio, or huge text, right? So large data, right? So you may need some techniques to learn all these stuffs. So the intelligence will be performed in network to nodes. I made a very simple example of a simple architecture for IoT. Sensors, actuators, and in between you have network to nodes. So the learning is happening in this network to nodes. When I talk about network to nodes, you can have cloud, fog, edge. So different levels of learning you can adopt here in this network nodes. So deep learning is typically very useful and powerful tool, learning process which brings more accuracy, and you can have some good devices. You can provide those devices either at cloud level or fog level or edge level, and you can make it more productive. And then you can create the intelligence in an effective way. So IoT with deep learning is very popular, in fact, right? So many applications are still being developed in healthcare, forecasting, personal assistant, smart transportation, and so on. The traditional approach typically is like this. You will have sensors, okay? You will have sensors, and all these sensors are just connected to the cloud. Okay, when I say network to devices, they only had cloud earlier. Although I was saying that edge, fog, and cloud is there in this network to node. These sensors, traditionally, what they did, they had only cloud. So here they connect Wi-Fi or some connectivity protocols, and these connectivity protocols are sending their data through some networks to the cloud services. Right, some cloud services. So what is, of course, cloud is good. In fact, scalability is good there. Learning capacity could be increased because deep learning, if you want to run deep learning, you can run very effectively in cloud, right? Because a lot of devices are available in cloud. So performing intelligence in such kind of device, such kind of environment is typically very good, right? And after getting the intelligence, you make the decisions, and that is given to the actuator, some sort of actuator, right? Actuator can do some actions. So this is the traditional way of doing it. So if I take an IoT application, the application will have some services running here, right? You will have to run some program on cloud, including the intelligence, all right? So say, for example, a patient monitoring system. So you will have the code that will be running in cloud. Where is this running? It will be running in EC2 instance, for example, if it is AWS, right? So it has to run here, and there will be some storage units attached to it, and all the sensor data will go to the storage unit, and things are moving like that. So depending on the scalability requirement, the number of EC2 instances could be increased and decreased and so on. So this is how normal, traditional way of an IoT application was looking like. But now we are introducing the concept of edge, right? So we are saying that not just cloud, you should think about a fog and edge, right? Which will be, so edge is typically very near to the sensors. So you have the sensor nodes, and the sensor nodes are typically connected to this edge servers and so on, where you get the computational, right? So why we need such kind of edge? Because you need to reduce the bandwidth, you need to improve the response time, you need to improve the security and privacy, like you have the video, right? And your IoT application, like patient monitoring application, has a video to check what is your status, and based on the video, you want to send the information to someone, right? So you want to perform some intelligence. If you're sending this image, your video to someone else, it is a privacy issue, right? So this is not a good approach. So to make the edge work properly, there is a concept of TinyML, right? TinyML, that is bringing the intelligence towards edge nodes, right? So instead of making the machine learning, deep learning, and all learning algorithms on cloud, now we try to bring the intelligence directly near to the edge. Okay, learning is now planned to happen in edge devices. As like in glasses, you should have some device, and this device should make some intelligence. It should make some decisions rather than sending all the data to the cloud. All right, so TinyML is typically very powerful. And how this learning is happening? There are three techniques, basically: federated learning, gossip learning, as well as transfer learning. So in federated learning, what happens is the learning happens such a way that you get one model, okay, one learning model. So when we say learning, it is finally some sort of mathematical equations which create some real representations, right? So you can then substitute some input, and you should get some output based on that model with some variables that you give there in that model. So if you are trying to create this one model with the help of so many decentralized edge nodes, okay, so in an IoT application, in the networked nodes, right? This is the network node. Sensors are here, actuators are here, right? In this network node, if you want to make a learning system such a way that the cloud may have some learning model, or it is trying to combine edges, right? All edges, which is connected with all the sensors, and it is trying to make the learning fulfill the learning process, right? Then that is federated learning, right? In the traditional approach, nothing happened like this. All the learning process was happening in the cloud-based systems, right? But now the learning is brought to the edge. When we are bringing the learning process to the edge, there are some ways how we can do that. One is federated learning approach. The second one is gossip approach, in which just it's like paralyzing the learning process, right? Decentralizing the learning process, but it doesn't want to be some kind of master slave approach, right? So Such a typical federated learning concept would be something like, you create the model which is distributed across many nodes in the in the edges typically, and from the edges you collect them, right? But in gossip learning, it need not be just edge nodes, right? It could be some powerful machines which just parallelly utilize all those things and try to execute them, typically either in MPI basis or OpenMP basis model. The next technique which they use, edge and the cloud and the fog kind of systems, all these systems typically edge nodes. That's why we are talking about edge intelligence. So when they use edge, is the next type is transfer learning. Here, the knowledge is basically like a teacher-student model, right? So whatever the teacher learns, he can have some model, and this model will be given to the student, so the student can use that, right? So imagine, right, like these are edge nodes, right? Less powerful. So you create something with the teacher, right? So like cloud can make real learning process, and then it can send the learning or findings, maybe the short form of that, to the edge, because the edge will have very little capability to do that. Right, so quick learning is done basically, and you can understand easily from there. So transfer learning is that kind of step. You can make the improvements better. You can improve the performance of these edge intelligence typically by if you take DNN, you can split the layers and you can provide the layers separately to certain edge nodes, and you can make the learning much faster, because learning should be faster. First of all, it should not create a lot of burden to the edge node. That is another issue. Because edge typically will be very low power, and it could not handle as like cloud. I have already told that. So people have tried to find some methods how to improve this learning process, to create such kind of ecosystem, to create the learning, not just cloud, because we told that just bringing learning to the cloud is not at all a good approach, because you need to have compromise privacy, network bandwidth, and so on. So pure cloud is not at all a possible good approach. Edge is always good to involve. And if you are involving them, some performance issues like this, DNNs, edge caching, and so on are there. So what is edge caching means? You create some sort of caches, right, to make the processing of edge quickly. And there are also some other good techniques. I'm just showing you some of the techniques here. Okay, like compression you can apply, because the models could be very, very large. Okay. If you take transfer learning concept like a teacher-student concept, cloud can create the model. It can be very heavy, right? Heavy in the sense, like more than 500 MB maybe, right? The model size of that model. So instead of transferring the entire model, you create the compressed model of whatever you learned, and you can provide them. There are some techniques. I would recommend you to read these techniques if you are really interested in that. How can we do this? Right? That is the important part, basically. Right? When I already made the point clear that we need edge intelligence, right? There are several ways how we can bring the intelligence towards the edge, right? You can improve the process of intelligence in the edge itself, because that is, decisions could be much faster, privacy could be improved, and so on. So there are some tools basically that provide them. Okay, one is TensorFlow Lite, right? So we all agree that cloud is fine. It has good scalability. You can create good models, very accurate models, and so on. But for many real-world applications, you could not fully stick to the cloud, right? So we need to process them with the help of edge. We need to process them something that should stay near to the sensor nodes, as like our human body, right? If something is happening immediately, our local units should act, right? So that's why. So some of the devices, okay, that are typically near to the edge are like our mobile phones, right? Android-based mobile phones, or Apple phones, right? iPhones, right? So, or Arduino boards, some Arduino boards, not all Arduino boards, which should be typically more powerful. We cannot call all devices as edge devices, right? The devices which are typically more powerful, SparkFun boards, ESP32 processor-based boards, right? Even smartwatches with some powerful systems, or Coral AI boards, Jetson Nano from NVIDIA. These are some devices that are used typically for performing this edge intelligence. That is learning in the edge side. Okay, how TensorFlow Lite supports this? Okay, so it is something for following this teacher learning or transfer learning approach, where you create the model in the cloud. Okay, and this model is transferred to the edge, okay, that is nearer to the sensors. So then this model is applied or used, okay, this model is used to infer or to predict something that is based on the sensed information or images, right? Like, say, for example, you need to classify flowers, fruits, or something like that. So you can use your edge device, your mobile phone or something like that. You can use them, and you can still do the inferences, because the learning is already done, and the model is already created, and it is created by powerful nodes, right? Little learning, little add up to the learning could be done here. Right, so TensorFlow Lite does that. So you should develop the model somewhere in the cloud or some powerful machines. You create the TF Lite files based on the model that is created, deploy the model to the embedded devices, and then you can use them to run. So how to create the model? You can do it by Python codes. TensorFlows are available, or you can use some browser-based tools. Here I am showing you the Teachable machine model, a tool. You can use them. You can you can provide the samples. Okay, like you can represent the classes what they want, and then it automatically creates the model, right? And it automatically creates the TF Lite file. Okay, and what you just want to do is you may need the end device, like Coral Edge TPU here in this case, right? That is a small board, an accelerator basically. You can use them, and you just offload your TF Lite, which is model which was created in a powerful machine. You load that to this small tiny board, and then you can start to use them, right? So the edge can start to perform. It is very small device, something like this, right? And with this you can start to make the inferences, right? So far what I have told is edge intelligence is definitely a good approach, right? You need to perform the intelligence not just in cloud, you should also do it in edge. And for this, we can use TensorFlow Lite and so on. This is what I was saying. But still there is another one issue. Okay, say in all the cases you will have cloud, you will have sensors, right? Some sensors. You can have edge, definitely, right? I was saying that edge intelligence is important, right? But in all these examples, what we have seen, cloud services if you take an IoT application, it's a program basically, right? In a cloud, typically to run this code, you should host this in EC2 instances, right? If it is AWS. So some cloud instance will be there to execute them. So if you don't use serverless, I'm not now going to talk about the serverless. So if you don't use serverless, what would happen is the EC2 instance will continually run. And imagine, let us take one use case. Assume that some patient is there. Okay, we need to calculate the diet of a patient. Okay, how much he consumes and so on. Whether he is there is imagine there is a camera connected to the place where he collects the food. Okay, and whenever he collects the food, we need to capture his face. We need to detect his face, right? And we also need to detect what kind of food he has collected, and we need to say that whether he is getting the diet food or not, right? If something worst case is happening, like he is trying to take chicken, mutton, and so on, so then he needs to be reminded. He needs to be informed that your health conscious may be poor and so on. So some sort of wearable, some sort of devices that are around are going to monitor this, right? So solution one is you directly connect to all the sensors like cameras directly to the cloud. Obviously, it is not a good idea because your face is privacy protected. Your information is simply sent to the cloud, which is third-party person. Edge is not third-party, like it is with you, right? So your data will not reach there, right? So second solution is edge, right? I was saying you can perform edge. So I create the model in the cloud for this face and everything. I create the model of bananas, what all food he has. Normally, it's there, and I create the attributes for that, and I create the model in the cloud. Offload that model to the device here, right? Some very small board, which will be very near to me, can make the intelligence, right? It can make the intelligence, and it can show something to me, right? Or give some good words to me saying that don't take this food, right? So such kind of edge intelligence could be kept here. And if something goes extremely wrong, I need to inform to the entire system, IoT application, typically, which will be like long years of history, which will be collected in the cloud. So if only second solution is used, only edge I will be using, right? And in the cloud, you should understand that the services will have to run continually 24 bars, 7 bars, something, right? And it will keep on running, which is the waste for us. If you take the IoT application, if you have 100 or 500 EC2 instances powered on throughout, you are just going to increase the cost, right? So this is not a good approach. So solution 3 is what we call it as serverless. Okay, in serverless, what happens is the EC2 instance will not run. Okay, it will not run. So the EC2 instance is not running. Rather, edge will do all sort of intelligence at the edge device itself, right? The mobile or some cameras attached with that microcontroller or microprocessor is making the intelligence based on TF Lite and so on, and it gives the information to the user and makes some intelligence and so on. And if some real anomalies are need to be reported, at that time, typically once in a while, maybe once in a week, it wants to send some information to the cloud. At that time, it will send in the form of events. Okay, and based on these events, the cloud instances will be created. Okay, so VMs will be created at that time, and only when the VMs are created, the cost is involved. So the state of that program as well as the the previous conditions of the entire IoT application will be stored in the storage, cloud storage. Okay, and once when you get the trigger from this particular edge systems, once in a while, like weekly once or maybe monthly once and so on, now the EC2 instance is powered on. The EC2 instance will do some calculations for the IoT application, update the state of the application, and report or send some actions to the users or some needed people, and then it will update the state, and it just vanishes. So there is no further EC2 instances running, right? So this is taken care by the infrastructure itself, right? Cloud infrastructures. So there are some cloud serverless architectures, like for example in AWS they have this Lambda functions and so on. So it is not just only at the cloud level you could do that. You can also do it at the edge level. You can do it at fog level. You can do it at the cloud level also. So typically these kind of architectures could be created, right? So that you are not running the more number of resources. That's what I'm coming to say. Typically in IoT applications, especially the application which I was mentioning here, you have to have the application running continually, but it should not always utilize your server, right? So of course there are some performance issues which you can definitely go through one of this article here. There are so many some issues are there with this serverless functions, and based on that how it should be done. So like some of that would be like a cold start and warm start issues of serverless. Yeah, so another research perspective of this topic would be like which computing node can be used, or which layer of computing should be used to execute here in different machines. Are they fitting to near optimal solutions and so on? All these are some of the research directions which you can take for. So altogether, what we have learned so far is what is IoT, and how this an IoT application will look like, typically like sensors, actuators, and in between we have some network nodes. And a traditional approach is like sensors will send to the cloud and the cloud will do the processing, but that is not a good approach. We can have edge intelligence definitely, so with some microcontrollers or microprocessors involved in it near to the sensors, you provide some intelligence or run the learning inferences there. Of course, edge could not do all machine learning things, or it cannot learn everything because of space, memory space problem, battery problems, or low power problem, computational problem. All these problems are there with the edge. So, but still we want to make them learn. So therefore, some techniques were discussed, right? Like federated learning, gossip learning, then transfer learning. And in transfer learning, I also showed you like you can apply Tensorflow Lite, which is you can create the model in the cloud. Some services are available. You can create the models. You can transfer the models to the edge systems, and you can infer them. So talking about the example where you want to measure the diet of some particular person, you need not learn the behavior of that patient by sending all the data to the cloud, but you can do it in the edge itself, right? And when you perform the edge intelligence, typically cloud is also connected basically, right? So it also needs information to make the entire IoT application to a successful one, because long history is needed for that IoT application, which will be processed obviously in cloud. So it is not a good practice, which is in solution 3, what I mean, right? It is not a good practice to always keep the cloud application running, right? So which will simply create a cost problem for you. So you can apply serverless. So these are some of the citations which you can definitely use in your references. And I would also like to take 2 minutes more, like we have this Indo-European hackathon with TUM Germany, where you can submit the ideas relating to IoT or edge intelligence typically. And if the winner will be invited to TUM Germany, which is ranked 38th in Times Higher Education, that ranking system. And we also have this Msme Incubation Center, where the successful idea could get 15 lakhs based on submissions through MSME. Then AIC, Atal Incubation Center, here we have support for nodal centers as well as seed fund support up to 50 lakhs per startup, right? So successful startup, right? So we are always eager to have good collaborations with people like you from different organizations where we can have joint development, consultancy works, and so on. Obviously, some sort of development for the growth of our nation, right? With that, I would like to take 1 more minute to thank our organizers, Sri Mohan sir, then CSI chapters also. I should also acknowledge IEEE officials as well as TUM officials for this, providing me this opportunities. Thank you so much.
So thank you very much for your excellent and informative lecture on edge computing and IoT. So there are some questions we have received from the registered participants. I will read out, yes, and you can answer them, sir.
Yes,
first
sir,
one is a little, I think it is they are asking detailed answer, but I will read out. But kindly discuss the case study of challenges in establishing smart city with IoT devices.
Okay. Smart city, obviously, it has to if you want to launch it to cities, permission will be one important point to think about. Like if you want to develop some, like for example, smart bin. There are so many solutions for IoT-based solutions for smart cities. First of all, you can think about smart bin. Logistics, right? Like you can have some sensors that will inform the smart city officials and some machines of smart city officials, so they can these machines can collect the sensitive information, and it can redirect the logistics. For example, collecting the waste from these bins. So logistics could be channelized, like routing could be channelized based on the sensory information in an automated fashion without the help of the users, right? Of course, for this, if you have developed such product and if you want to launch it, then you will need permission from the smart city officials to make it happen.
Thank you, sir. The next question is, what is the research scope of edge intelligence for health monitoring?
I think there are so many good examples for healthcare. Edge, like nowadays you also have in mobile phones, like monitoring the health and so on. But if you have developed an IoT-based application, all this sensed information could be collected to this edge node, right? And only the major inferences could be sent to cloud, right? So healthcare, there are so many applications. I think I gave one slide relating to healthcare. Like fall prevention is also one of the important application, which nowadays people are thinking about, like when someone falls down, like especially when they are old age, they fall down and they broke their bones, right? So there are some textiles, you can, it immediately opens the airbag, and so nothing will happen to him, right? Similarly, there are so many applications. I have a publication relating to healthcare applications. I recommend you to, or I could, I could share the link. Maybe you can watch it in, in the link which I have it.
Thank you, sir. The next question is, what problems could result if there is a loss in data in edge intelligence?
Okay, yeah, that can happen in several levels actually. So there are several protocols for supporting this. Even if you take constrained application protocol at the service level of IoT, it has some mechanisms like messaging things. You can look into that aspect. Or if you take lower level, lower layer of IoT, like I take IEEE 802.15.4, the frames are designed such a way that even if some data is lost, you can consider that still. Apart from layering, there are also several examples, several techniques where you can you can benefit from this data loss. Especially, if you take a MQTT protocol, it has this publish subscribe model where you don't create the TCP kind of connection, because normally the data will be lost or the connectivity will be lost, and because of that the data is not transferred between the sensor as well as the connected services. So when you use MQTT based communication protocol, you provide this, you provide publish subscribe model. So whenever the sensor is there and whenever the data is available, it publishes, and whenever the subscribers are available, it is collecting the information. So there are several techniques at various levels for solving this issue.
Thank you, sir. The next question is, what is the difference between fog computing and edge computing?
Okay, I think I answered this. Fog is slightly higher computational power, which is, you can imagine like in a smart city, in one location you are having a big cluster. Okay, then that is fog. But if cloud is, obviously you can understand it is like big data centers with more scalability and more computational power. We can differentiate this with respect to compute capability, the locality of where the computations are resided, right? Edge is typically the computational unit which is less powerful, which is very near to the sensor. So this is how it is classified.
Thank you, sir. The next question is, how scheduling or load balancing idea can be applied from IoT to edge to cloud scenario?
Okay, I think you can look into this new upcoming techniques like split computing, where they talk about scheduling the, especially when you talk about intelligence. When you describe deep learning, the layers are split into smaller portions, smaller chunks, and some layers are sent to some computational units, and some layers are sent to some other computational units. So like that. So you can apply some scheduling algorithms also. There are some works already available. You can use them, I think.
Thank you, sir. Next question. How is edge AI crucial in automotive, especially coming up in electric vehicles where everything is software controlled?
Sorry, once again, sir.
How is edge AI crucial in automotive, especially coming up in electric vehicles where everything is software controlled?
Okay, it's you can imagine as like a normal edge application only, but only thing that is different in vehicles, basically automated vehicles, is it has to be more real time, right? So and the microcontrollers, what they use, what they apply at the edge, will be a little bit more powerful. Think about some applying some ASIC-based, I mean application-specific integrated circuit-based designs that are used in the edge. So by doing that, you can increase the inferencing speed, which is very important for vehicles. But other than that, the generic concept is going to be the same.
Thank you, sir. The next question is, would you please give examples of real-time applications used in IoT?
I think I have explained many of those examples.
Yes.
I think that's fine. No.
Okay, sir. The next question is, how to mitigate the security challenges with the IoT framework? Okay,
security is very important and crucial aspect in IoT. There are at protocol level also, there are some protocols that provide this security features. Like some examples are secure MQTT. Okay, that is a protocol which provides a secured model. Apart from that, there are few works relating to data immutability features, right? Like applying blockchains for that. Or there are some works where they provide security at the cloud level, right? Security is a broad topic, basically. You can narrow down to your own specific problems, either in the layer level or communication level or intelligence. Even the if you talk about deep learning adversarial networks, you create big problems if you provide wrong advices, right? Intelligence is given in a wrong fashion can create extremely wrong solutions, right? And there are some examples with the MQTT even where the topics are sent to some devices, and these devices are collecting the topics such a way that to open the door, close the door, right? So since machines are communicating to the other machine without the proper security features, it could simply open the door, right? So that is one important topic of discussion. Of course, it is which you should if someone is interested, you can also talk to me. That is a good topic, actually.
Thank you, sir. The next question is, can we get NLP services using IoT for low resource language to use NLP process?
Sorry, sir, can you once again?
Can we get NLP services using IoT?
Energy services?
Yes. Natural language process services.
NLP services, okay.
Using IoT for low resource languages to use NLP process.
Yes, sir. Like, with the help of this transfer learning, the example what I have shown with the TF Lite model, you can easily apply. Okay, so you create the model in the cloud with large data sets and different tasks, then offload that to edge nodes. You can obviously make NLP stuffs working with the microcontrollers or microprocessors there in the edge level.
Thank you, sir. The last question: can you suggest an optimal heuristic algorithm for cloud scheduling?
Cloud scheduling?
Yes.
Okay. That may be something different from what we are describing. Okay, but there are so many meta heuristics algorithms, right? Several of those are, that is old topics actually. But you can, if someone is interested in cloud scheduling or something related to that topic, you can orient your research towards IoT context. So if assuming that IoT data or IoT applications are handled using cloud resources, then what kind of scheduling could be applied there? right? So typically nowadays, my talk was more towards the serverless architectures. So serverless is, serverless architectures are governed by the providers itself. So we, as a third party, you can do very little there. If you design the application as with the help of a private cloud setup, you can do something there. But other than that, you cannot do much, right? So if you want to do it with private cloud, typically with OpenStack or something, and then down the line you can use OpenWhisk or Kubeless basically on top of Kubernetes. So this becomes a platform where you can then investigate some heuristic algorithms to control yourself, right? So several meta heuristics are there. Of course, threshold accepting, particle swarm optimizations, and so on. All historical, traditional scheduling algorithms could be applied there. Yes.
Thank you, sir. These are some of the questions we have received from the participants.
Yes,
so
sir.
Now we will move to the formal vote of thanks, and I invite CSI Chairman Dr. T.V. Kamalakannan to propose the formal vote of thanks. Kamalakannan.
Thank you, Dr. Saktivel, and thank you, everyone. I would like to propose a formal vote of thanks on behalf of all the three organizing units, ACM, IEEE-CS, and Computer Society of India. I would like to formally start thanking Dr. Shajulin Benedict, who has been so kind in coming to us during the weekend and so nicely explaining what IoT is. And of course, I'm not going to summarize everything what he has said. But I think as the audience, I've been carefully observing, you are so nicely elucidated what is IoT is and what are the applications of IoT and the huge investments that are going in IoT. And today we all know that this all, it is internet of everything. I had seen a movie called Eagle Eye a long time back. Wherever you go, you get tracked, and the whole universe can actually track you. Okay, you can always put your settings everywhere, but then as somebody said, we need to be very careful about our security considerations also to IoT. And you went on to explain the building blocks of IoT, the sensors, actuators, and then networked devices. I'm reminded of the movie Avatar, right? Where it's beautifully connected and how our man goes after night 3 and all that, right? So I think that movie is no longer a fiction. So whatever you described today, it resembles that scenario. So, and also you nicely moved on to why we actually bring edge to IoT. Since IoT is becoming so data intensive and so computational oriented, so obviously the more you move to the edge, the more personal it is, the more safe and secure it is. So you beautifully explained that. And I'm reminded of, the client server architecture that the oldies are familiar with in 1990s. So, we all know that it all started with the server-based, the whole IBMs used to process everything. And then we invented something called client server architecture. We tried to move the programs, algorithms to the client in 1990s. Then we thought it's too much, we dispensed with it. And then we came out with the web-based applications. And today, it's very similar to that, right? We are moving all the computational power to the edge where actually the user is consuming. So that, one, it is speed, it is fast, it is safe and responsive. You so nicely explained all of that, Dr. Shajulin. Thank you so much. And the practical applications also you had covered. And you also talked about the learning techniques, right? This is the first time I heard TinyML, right? How do you use the learning techniques, even for edge? So overall, I think it has been a fantastic presentation. We are all personally enriched by your presentation, Dr. Shajulin. Thank you so much. And also the way you fielded the many questions very nicely and lucidly explained. So thank you so much. And I would like to thank all the participants who dialed in and stayed up to this minute. So thank you very much. In spite of the weekend, you all joined. And I would like to thank all the organizing units also. So thank you all. Thank you very much again. Have a nice weekend, whatever is left of it. So
Thank you, Shajulin.
Thank you, sir. Thank you.
thank you. We'll be in touch.
Yeah.
Thank you, Mr. Shajulin.
Bye. Thank you, everyone. Bye.
Thank you very
Bye.
much for the informative session.
Thank you so much, sir. All